Hey guys, before we get too far into things, I want to go ahead and review what we learned before Thanksgiving break. We started talking about congruent triangles. So the word congruent, as Destiny always says, is everything is the same size and same shape. So for triangles, that means we have all three sides are congruent, all three angles are congruent. So for instance, if I have this triangle here, okay, and we'll say maybe this is and if I claim that these are congruent to each other, in this case it would be by SAS, which we're going to get to that in a little bit. If I just want to go ahead and write a congruence statement, so that's just a statement that says triangle blah 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 is congruent to triangle blah blah blah. So if I say this is triangle HAC is congruent to, and I want to name that triangle, we have to remember that we're going to name it in a very particular way. You can't just pick these three letters any way you want. They need to make sure that we need to make sure that they correspond to the letters of this triangle. So angle H is the right angle in this triangle. So it has to correspond to angle D in this triangle. So that'll be the first letter, D. And then angle A, you can say, well, that angle is across from the side that has two tick marks. So it must correspond in this triangle to the angle across from two tick marks, which is B. So D, B, and then obviously the last one that we just have is T. So that means all of these angles, H and D, are congruent, A and B are congruent, C and T are congruent, and then all the three pairs of sides are congruent too. So this here is called a congruence statement. It's claiming this triangle is congruent to that triangle. So then the next thing we talked about was, well, how can we prove these triangles are congruent? So obviously if we know all three sides and all three angles, then we know they're congruent for sure, but we're lazy and we want to know, what is the least amount of information that we need to prove that they are congruent? So side note, remember this is the symbol for congruence. It's the equal sign with the squiggly on top. So there were 5 different ways that we could prove triangles are congruent. The first one of those ways was called SSS. And it's pretty self-explanatory. Obviously, it stands for side, side, side. So we said things like, if the 3 sides of one triangle are congruent to the 3 sides of another triangle, then that's enough. We know that everything else is congruent too with those triangles. Now, the thing that you have to remember about with SSS, or with any of these for that matter, is if I draw a shape kind of like this, and I say that, this side's congruent to this side, and this side is congruent to this side. As it is, I know that this has 2 pairs of congruent sides. But remember, there's something called the reflexive property that says that anytime a side is shared with the triangles, then it is congruent to itself. So that's the reflexive property. And so we'd say these were congruent by SSS. Notice we don't have any information about angles, and we don't need any information about angles. The next one was SAS, and it stands for side, angle, side. And it's if you have something, let's say, so if I gave you a shape that looks like this, these 2 triangles, right now, we know these 2 sides are congruent, we know these 2 angles are congruent, and again, by the reflexive property, we are allowed to conclude, oh, well, this side in between is also congruent. So by SAS, the key here is that the angle has to be in between the 2 sides, which it is right now, right? Here's the angle, and then here are the 2 sides on the other parts of it. This gets confusing because we also have ASA. So this it's kind of the same thing, but just opposite. So it's angle, side, angle. For that, we might have something like, let me give you a good example here. If I just have a triangle that looks like this. something like this. Two pairs of congruent angles, and the side between them is congruent. So that's ASA. Again, the side is between the two angles. Okay. We also have AAS. So these two are actually kind of challenging because they both have two pairs of congruent angles and only one pair of congruent sides, but it's the placement of the side that stands them apart from each other. In this one, the side is between the two. In AAS, the side is not between the pair of congruent angles either. So that one would look something like this. So, two pairs of congruent angles, these two here, but notice the side is not between them. The side is on the other side. Shouldn't say that. The side is not kept between the two angles, okay? It is here. So those are going to be the confusing ones that we're going to have to be careful of. The last one sounded a lot different from all of the others, but it's equally as important. It is called HL. HL, if you remember, stands for hypotenuse leg. So this is only for right triangles. Only for right triangles. Okay. So it's if we have something like this. So again, we're going to have to look for the right angles. Ooh, it's a lovely looking triangle I drew there. They have to be right angles. We have to know that the hypotenuse is congruent to each other, and just one of the other legs is congruent as well. It doesn't matter which one. Sure, that works. Hypotenuse leg. Right triangles, hypotenuse are congruent, legs are congruent as well. You're going to have to be extremely familiar with these 5 because that's what we're going to use for our 2-column proofs. So we have one more thing to learn, and then it's just a matter of reviewing all of these and making sure that we can use them under any scenario that we're given.